In this video, I am going to give you examples on how to solve higher order derivative problems. Okay, I have 7 examples here for you. Let's answer the first one. Okay, so here it says find the third derivative of the function negative x raised to 4 plus 5x cubed minus 4x squared plus 7x minus 10. Okay, so for the first derivative, so this will be equivalent to negative 4x to the third power plus 15x squared, right? Minus 8x plus 7. So that's the first derivative. Now we need to find the second derivative. That depends on the first, of course. So let's just continue the process. This will be negative 12x squared plus 30x minus 8. And then the third derivative. So this is negative 24x plus 30. There you go. All right, let's go to the next example. Here we need to find the second derivative. Okay, so first derivative, but before we do that, oh no, there's no need for us to rewrite this. Okay, so let's find the first derivative. So that's 4 over 3 times 5 x, and then this is minus 3 over 3, right? So that's 1/3. Okay, 20 over 3 x raised to 1/3. That's our first derivative, by the way. Now let's go find the second derivative. So that's 1/3 20 over 3 x. So 1/3 minus 3 over 3, which is negative 2/3. So now we have 20 over 9x raised to negative 2/3, or if we want to put that in the denominator, or we want to make the exponent positive, this will be 9x raised to 2/3. Or if you want to make the exponent fraction, if you want to convert this x raised to 2/3 into radical, we can do that. So 9 cube root of x squared. So the denominator is your index, that's 3, and the 2, which is the numerator, that will be the exponent of your x. Alrighty, let's go to the third example. Okay, so for this one, we need to apply the quotient rule. These are f and our g. So for the quotient rule, we have f prime g minus f g prime all over g squared. Let's solve first the first derivative. Okay, so that's derivative of x is 1, g is x plus 2, minus x, derivative of x plus 2 is 1, divided by x plus 2 squared. Okay, equals x plus 2, 1 times x plus 2, minus x, all over x plus 2 squared. We can cancel the x and negative x, and that's going to give us the first derivative, which is positive 2 over x plus 2 squared. And again, we will derive this to get the second derivative using the quotient rule again. So derivative of 2 is 0, and then x plus 2 squared minus 2 times. So for x plus 2 squared, we will use the chain rule. Just to remind you about this, I'll rewrite that on top. So this is equivalent to 2 times x plus 2, right? And then the derivative of x plus 2, which is 1. So this is 2 x plus 2 times 1, all over x plus 2 square. Okay, this side of our expression will be 0 because of that, 0. So we have a 2 and a 2 and a 1, so that's negative 4 times x plus 2 all over x plus 2 to the fourth power. And if you notice, we have the same factor, which is x plus 2. There's 1x plus 2 on top, and then in the denominator we have 4x plus 2, so we can cancel this x plus 2, and that 4 will become 3. So our final answer is negative 4 over x plus 2 to the third power. Okay, so here we need to find the fourth derivative. See that symbol? If you see that, that means we need to find the fourth derivative. First derivative is 7 minus 6 x raised to negative 4, right? Negative 3 minus 1 is negative 4. So this is f prime x. F 2 prime x is, that will be 0. So plus 24, or 24x raised to negative 5. Okay. Third derivative will be negative. So 24 times negative 5 is equivalent to 120. Yep, negative 120 x raised to negative 6. This is big right here. Okay, negative 6 times 120 excuse me, 720, that's positive, x raised to negative 7, or 720 over x raised to 7. Alrighty. Fifth example. Second derivative of 3x squared plus 4x minus 8 all over 2x. I don't want to use the quotient rule, so what I'm going to do is this. I'll separate this into three terms. 3x squared over 2x plus 4x over 2x minus 8 over 2x. So if we do that, we can simplify this. 3 over 2x, right? 3 over 2x plus, cancel the x, 4 and 2 is just 2. And then minus, this is 8 over 2, which is 4. And then let's make the let's make this a let's use the loss of exponent here, and then that x in the denominator will be x raised to negative 1. Okay, so again we just rewrite everything. Let's find the first derivative of this one. This is 3 over 2 plus 4x. Okay, and now for the second derivative, that'll be equal to 4. Okay, so I believe it's a lot easier if you do that rather than using the quotient rule. Alright, second to the last example. Okay, so the given is the second derivative, which is 4 squared of x. We need to find that third derivative. Well, that's not really hard. It's just like finding the first derivative, because this is already the second derivative. So let me just rewrite this first. 4x raised to 1/2. So the third derivative is 1/2 times 4x, and then 1/2 minus 2 over 2, which is negative 1/2. 1/2 times 4 is equal to 2x raised to negative 1/2. If you want to make the exponent positive, this will be equal to 2 over x raised to 1/2, or 2 over square root of x. So actually, any of these three is acceptable. So again, it really depends on your teacher. Okay, so I'm gonna end with this problem. I have two problems here. We need to find the f of 4 and the f of 5. So let's start with the f of 4. If the problem is, if you see that the 4, and that's the same as the highest exponent, then that means you need to just get rid of that. because eventually all of this will be equal to 0. Okay, so that's the shortcut. Just focus on that, negative x raised to 4. Okay, that's our function. So that's our f of x. So for the first derivative, it's negative 4x raised to 3. For the second derivative, that's going to be negative 12x squared. And then for the third derivative, this will be negative 24x. And then finally, for the fourth derivative, that will be negative 24. And if you notice, at the fourth derivative, it will be a constant number, right? So obviously, oh, sorry, for the fifth derivative is equal to 0. So that tells us two things. Number one, if these two matches, meaning the exponent, the highest exponent is 4, and you're looking for the fourth derivative, ignore the rest of the terms, focus on that, and solve for the fourth derivative. However, if the question is just f raised to 5, or we need to find the fifth derivative rather, there's no need to solve this because the answer for that will always be equal to 0. And why is that? Because 5 is one more higher than 4. So just in case you encounter that kind of problem, the answer will be 0. For example, you have another example. This is the last one. You have an x raised to 3 plus 5x squared, let's say minus x plus 10. And then we need to find f of 4, or sorry, the fourth derivative of this function. Since 4 is 1 greater than 3, the answer will just be 0.